Hello students, myself Harshal Nilkanta Nemade, lecturer in Mechanical Department at Praveen Patil College of Diploma Engineering and Technology. Starting with Chapter 2, Process Engineering, Part 2, I will talk on hyperbolic cooling tower and waste heat recovery in process industry. Now, learning outcomes. By the end of this chapter, the students will able apply heat engineering in process boiler, understand the ultra supercritical boiler, understand hyperbolic cooling tower, waste heat recovery system used in process industry. Hyperbolic cooling tower. Hyperbolic, sometimes known as hyperboloid, sometimes is known as hyperbolic cooling tower have become the design standard for all the natural draft cooling towers. It is defined as density difference between atmospheric air and the hot gases in chimney. Purpose of cooling tower is to reduce the temperature of circulating hot water to reuse this water again into the boiler. This hot water is coming from the condenser. The shape is a hyperbolic, so it is called as hyperbolic cooling tower. The hyperbolic shape also aids in accelerating upward convective airflow, improving the cool efficiency. Okay, you may see the diagram of hyperbolic cooling tower working. Hot water is coming from the inlet of the tower and pumped up to the header. The header contains nozzle and sprinkler which is used to spray a water, and it will increase the surface area of the water. After the water comes to the cooling fields, the speed of the water is reduced. Because of slow speed and more contact air area of the water, it becomes a good connection between the water and hot water. The air moves from the bottom to the top due to the density difference. The process will reduce the temperature of the water by evaporation process, and cool water is collected in the bottom of the cooling tower, and this cool tower water is used again in the boiler. Effectiveness. This is the ratio between the range and the ideal range in percentage, that difference between the cooling water inlet temperature and ambient wet bulb temperature. Effectiveness is given by range upon range plus approach. The higher is the ratio, the higher cooling tower effectiveness. Waste heat recovery process industry. In power generation and process industry continuously produce large amount of the hot waste gases and then dumped into the environment. Even though it could still reuse some useful and economic purpose. These waste gases have been practiced for a long time of the generation of steam power. The waste gases temperature can be at high, medium or low at 100, 500 or 300 degrees Celsius respectively. Waste heat boilers, the device that cools the gases and produces the steam, are generally called as waste heat boiler. The supplementary fuel may or may not be required. The two types are heat recovery steam generator, its abbreviation is HRSGS in a power plant. Gas turbine GTS exhausts large amount of the clean medium hot gases used in the boiler, usually called as HRGSGS, or a turbine exhaust gas TEG boiler. Waste heat recovery boiler WHRBS in a process industries, in metallurgy, cement and similarly plant, large amount of the dust hot gases generated are clean and closed steam is produced in a boiler generally known as the waste heat recovery or boiler WHRBS in a process industry. Waste heat recovery boiler in the process industries are bulky and expensive. The cost of steam and the power generated is higher. Waste heat recovery boiler, we see now what is the waste heat recovery boiler. Waste heat recovery boiler are ordinary water tube boiler in which the hot gases from the gas turbine pass over the number of the parallel tubes contains water. The water is vaporized in the tubes are collected in the steam drum from the which it is drawn off. Use the heat or the process steam because of the exhaust gas are usually in the medium temperature range in order to convince the space or a more compact boiler can be produced. If the water tube boilers are fined in order to increase the effectiveness heat transfer area on the gas side, figure shown on the mud drum set of tubes over which the hot gases may a double pass, and a steam drum which collects the steam generated above the surface pressure at which the steam is generated, and rate the steam production depends on the temperature of the waste heat. Pressure of the pure vapor in the presence of the liquid is the function of the temperature in the liquid from which it evaporated. Water tube boiler that use medium to the high temperature exhaust gas to generate the steam in case of producing the desired level of the steam auxiliary to attain the higher steam output. The steam can be used to produce process heating for the power generation. Recuperators. The recuperators is a heat exchange device that takes place between the flue gases and the air through the metallic or ceramic valve. Duct or the tube carries the air combustions to the preheater. The other side contains the waste heat steam. The recuperators is used recovering the waste heat from the flue gases. Types we will see: metallic radiation recuperators, reactive recuperators, convective recuperators, ceramic recuperators. The figures are shown. Okay, you may see regenerator. The regenerator, which is preferably for a large capacities, has been very widely used in the glass and steel melting furnace. Important relations exist between the size of the regenerator, the time between the reversal thickness of the bricks, convective of the bricks, and heat storage ratio of the bricks. Heat wheel exchanger. A thermal wheel, also known as a rotary heat exchanger or a rotary air to air enthalpy wheel or heat recovery wheel, is the type of the energy of recovery heat exchanger positioned with the supply and the exhaust air stream of the air handling subsystem or in the exhaust gas of the industrial process. A heat wheel is growing application in the low, medium, and waste heat recovery system. Heat pipe. The heat pipe is a thermal energy absorbing and transferring system and have no moving parts and hence required a minimum maintenance. A heat pipe can transfer up to 100 times more thermal energy than the copper. The best known is conductor. See the figure. This is the heat pipe. Economizer. Economizer are the mechanical device intended to reduce the energy consumption or to perform the useful function such as preheating a fluid. The term of economizer is used to purpose as well the boiler, power plant, heat regeneration, ventilating, and the air conditioning. In case of the boiler system, economizer can be provided to utilize the flue gas for the preheating of the boiler feed water. For every 22 degrees Celsius reduction of the flue gas temperature through economizer or a preheater, there is a 1% of save of fuel on the boiler. Shell and tube heat exchanger. The shell and tube heat exchanger is most commonly type of the heat exchanger in oil refinery and other large chemical process is suited for the higher pressure application. As its name implies, these types of exchanger consist of the shell with the bundles of the tubes inside it. The medium containing waste heat is a liquid or a vapor which heats another liquid. Then the shell and the tube heat exchanger must be used, since both paths must be sealed to contain the pressure of their respective fluids. Okay, you may see the diagram of shell and tube heat exchanger. Plate heat exchanger. The plate heat exchanger used for a metallic plate to transfer the heat between two fluids. This is a major advantage over the conventional heat exchanger that the fluids are exposed to the much large surface area because of the fluids are separated out over the plate. The plate types of the heat exchanger consist of the series separated parallel plate forming the flow path. Each plate is separated to the gasket and the notch stream pass parallelly through the alternative plates. The liquid which is heated flow in a parallel between the hot plates to improve the heat transfer of the plates are corrugated. Thermocompressor. The thermocompressor is the device which converts low pressure steam to the high pressure steam and relieves to the medium pressure steam, where the high pressure steam is accelerated into the high velocity fluid through the nozzle. The large amount of the steam is in the form of the latent heat, and thus the thermocompressor compressing would be a large improvement of the heat recovery. It is used in evaporator where the boiling steam is recompressed and used as the heat steam. Direct contact heat exchanger. In direct contact heat exchanger, low pressure steam is used to preheat the feed of the water or some other fluid. Direct contact heat exchanger used in the steam generation station. Okay. Thank you.